Hey Bobcats, it's Mr. Peterson. Today we're going to be talking about radical functions. Um, just to review you the idea of a radical, that's the square root symbol. So these would be functions that involve um, the square root symbol, so to speak. So our learning goal today is to be able to graph and transform radical functions and inequalities. A radical function is a function whose rule is a radical. For example, we would have like a cube root or a square root. We also saw today that when you have a radical function, such as plus or minus the square root of x, we wind up seeing that that's the inverse of a quadratic. So then we can draw the conclusion that the inverse of quadratics are square root functions. And we'll talk more about cube root functions and cubes later on, but that is something we'll consider as well. So first of all, we want to graph the function and identify its domain and range. So when we do this, since the function is the square root of x, when we make our table, we want to pick values that would, when we put them under the radical, they would give us whole numbers. For instance, like 1, 4, 9, 16, all of our perfect squares. And the reason for that is if we pick the number 2, yeah, we can do that, but it's going to give us a number that's going to be hard to find its exact spot for. All right, so first of all, before we start making our graph, let's build the table. So, and again, like I said, let's choose some values for x that will be perfect squares. So, for instance, when I plug in 1, the square root of 1 is 1. I'll write that over here. When I plug in 4, the square root of 4 is 2. When I plug in 9, the square root of 9 is 3. When I plug in 16, the square root of 16 is 4. All right, so now let's make a graph to see what that looks like. Here's my x-axis, and here's my y-axis. I'm going to start way over here because of my values. Also, let's try one more. Let's say 0. Oh, I forgot the 4. 0. If we plug in 0, we get out 0. So we're going to have, in our graph, we're going to have 0, 0. We're going to have 1, 1. We're going to have 4, comma 2. So there's 4, 2. We'll have 9, 4, 5, 6, 7, 8, 9, 3. And then I can't go any further because my graph doesn't have enough room, but you can kind of see that that is what we have as our graph. And so you might be saying, okay, Mr. Peterson, I don't understand why that doesn't look like the opposite of a parabola. And we got to think, first of all, this is only the positive values that would be true. If we put in negative values in for x, we would wind up with the second half of our graph, which would be the kind of the mirror image of this, the reflection of this, and it would look something like this. So now you can see that it does make a parabola that's kind of been turned on its side. But for this one, they did not say plus or minus x. They just said what is the values for x for the square root of x. So when we're going to be specific just to that, we would say that our domain, those are for the graph that we have here. Our domain is x such that x is greater than or equal to 0. That's our domain. And our range, and since we limited it to just the positive ones, the range would be y such that y is greater than or equal to 0. So that's the domain and range for this function. All right, so why don't you guys try this one? In your notebook, make a table and a graph, and then you'll answer this question about the domain and range. Okay, transformations. The transformation rules are the same as they've always been. And I'll give you a second just to kind of hit the pause and record some of this down. Again, we want to pay close attention to the stretches and the compressions, because those I think are ones that we always struggle with. Notice that if we're doing a vertical stretch or a compression, we're multiplying the whole function by a value. When we do a horizontal stretch or compression, we're multiplying what's underneath the radical by something. And we want to note that, for instance, we're doing the inverse, or the reciprocal of this. So if it's 1/5, your stretch is going to be by 5. If it's 3, your compression is going to be by 1/3. Reflections have the same rules. Vertical and horizontal translations have the same rules. All right, so we want to graph these two and describe the transformation of each function. So g of x for a here is the square root of 2. So square root of 2. It's the square root of x minus 2. Square root of x minus 2. Nope, not under the radical. We want to make sure we move it outside the radical. So that moved us down 2 units. Down 2 units. Okay, in example B, it's 3 times the square root of x. 3 times the square root of x. So delete that. And then put our cursor right there, 3 times the square root of x. And I'm going to go ahead and bring back in the square root of x, just so that you can see that one as well. The red one is our original, the parent function. The blue one is our transformed function. And as you can see there on that one, we did a vertical stretch by 3. And just to look back at that table from your notes, we multiplied the whole function by 3, so that wound up doing a vertical stretch, since our number was bigger than 1 that we multiplied by. All right, so what am I trying to get to? I'm trying to get to this. I want you guys to do this one and this. Sorry about that. Hold up. I want you guys to do this one and this one. All right, we'll see you in class today.